Let's move on to section 1.6, where we're going to focus a little more on complex inequalities. Compounds and inequalities, we discussed a little bit before. It's a combination of two inequalities. There's two types. One type is called an and inequality. And just means the answer must satisfy both, and the graph would overlap. We'll see this when we're actually working through the problems. This is a little bit of a shorter section. The other type of inequality is an or. And this is just where at least one or both inequalities must be satisfied. On a graph, this would just look like coverage. I'll show you what this means. Example is just going to say to solve. Here we had -4 is less than x minus 2, which is less than 5. This is a compound inequality because there's two inequalities here. The way we solve a compound inequality is the same way we solve a regular inequality. Try to get that x by itself. So you want to try to add 2 to both sides. You can't just do one side. Whatever you do to one side, you must do to the other. And you just wind up with -2 is less than x, which is less than 7. We're going to graph this. -2 and 7. We put parentheses on both. In interval notation, we write this -2 to 7. One thing to clarify, and inequalities, signs must point to the left. When combined. What I'm talking about is for this problem, this would be an acceptable answer. This is what you're going to have to do on my math lab. But you don't want to do this. You don't want to say -2 is less than x, which is greater than 7. This is bad. And you also don't want to do like -2 is greater than x, which is greater than 7. This is bad too. They must point to the left. If you have an and inequality like this, where it has to be less than 7 and greater than 2, you have to write the inequality where all the signs are pointing to the left. We can have compound inequalities that look a little different. What if we had 2x is less than or equal to 4x plus 8 and 3x is greater than or equal to negative 9? Sometimes you could have and inequalities that are combined. Sometimes you could have them separate. Whenever you have inequalities combined, those are and inequalities. Let's go ahead and work through this. We'll subtract the 4x on both sides. At negative 2x is less than or equal to 8. Divide by negative 2. We have to switch the sign. And if we're working on the right side, we have to divide by 3. We get x is greater than or equal to negative 3. When we go to graph this, negative 4 is negative 3. We're looking for all numbers that are greater than negative 4 and greater than negative 3. This is a little bit of a different problem. Do you know what the answer would be? We're looking for overlap here, because it's an and problem. Where on this number line is the graph overlap? And we're looking for overlap. So what we would say for this as an answer is we would just say from negative 3 to infinity. But if we had x plus 2 is greater than 3 and 2x plus 1 is less than negative 3. All right, well, we could solve this. Subtract the 2 on both sides. X is greater than 1 and 1 over here. Divide by 2. X is less than negative 2. We're looking for numbers that are greater than 1 and numbers that are less than negative 2. We're looking for overlap. Let's draw it on a number line. Here's negative 2. Here's 1. Where do you see overlap on the number line? It said there's no solution. The way we would write this answer is we'd just put this symbol, which is null. We did talk about that in one of the previous classes. There's no solution. If the answer isn't 0, 0 is a number. If there's no solution, we put a 0 with a line through it. That means that there's no solution. want to talk a little bit about OR problems. What if we had x minus 1 is greater than 2, or three x plus 5 is less than 2x plus 6. Remember, for OR, we're just looking for coverage. Anywhere on the graph that's covered is going to be part of our answer. For AND, we're looking for overlap. For OR, we're just looking to see where is there coverage on the graph. On the left side, we could add 1. Add x is greater than 3. On the right side, we could subtract 2x. Numbers greater than 3 would be over here. Numbers less than 1 would be here. We're just looking to see where is there coverage on the graph. We talked about this a little bit in the first section. It looks like we have a graph from negative infinity to 1. We also have a graph from 3 to infinity. We combine the two answers with a union sign. There are a couple strange situations that happen with OR. What if we had a problem where it was x is less than or equal to 5, or x is less than or equal to 2? What would be the best answer for this? Remember, for OR, we're just looking for coverage. We have numbers less than or equal to 2. We have numbers less than or equal to 5. We want to write our answer as just where is the graph shaded? Where is there any kind of line on the graph? What do you think the best answer would be for this? Negative infinity and 5. Very good. Negative infinity to 5. We're just looking for coverage. And remember, the 5 has a bracket on it. Very good. Oh, Liquin. Thank you, Liquin. Yep, that's good. Sometimes people have a hard time understanding this, but not Liquin. We're just looking for coverage on our number line. If it was an AND problem, we're looking for overlap. So it's important that we understand the difference. One last example with this, and then we'll move on to our last section tonight. What if we had x is less than or equal to 5, or x is greater than or equal to 2? Remember, when we're looking for coverage, here's all numbers that are greater than or equal to 2. Here's all numbers that are less than or equal to 5. Negative infinity to positive infinity. The entire number line is shaded, right? If this was an AND problem, we would just be looking at this middle. It's important that we know the difference between OR and AND. All right, so our last section today, we have about a half hour to go.